Okay, we're picking up where we left off on the review for the Math 110 final exam. Starting at number 37, it says to determine if x plus 2 is a factor of the polynomial f of x equals x cubed minus 3x squared minus 7x plus 6. All right, as I mentioned in the previous video, previous problems, this is actually asking the same thing as if when you divide this polynomial by x plus 2, you get 0, right? So the question is here is x plus 2, I'm going to put it in parentheses because we usually see it in parentheses as a factor. Is it a factor of f of x equals x cubed minus 3x squared minus 7x plus 6, meaning can we write this polynomial as, let me do it below it, as x plus 2 times another factor, right? Is it a factor? And that's going to be true, in other words, if x equals negative 2, if you set that equal to 0, you get x equal negative 2 is a 0. Or if the point negative 2, 0 is an x-intercept, that would be equivalent because x equal negative 2 is a real number. That's also equivalent to when you divide, you get 0 for a remainder. You get a remainder of 0. So all these questions are asking the same thing, and they're all answered using synthetic division, where we put a negative 2 for the potential 0 outside the division sign, and the coefficients of the polynomial, making sure that there's no powers of x missing. If there's a power of x missing, you need to fill in a 0 coefficient. But we've got 3, 2, 1, 0. We've got 4 terms for cubic. So we're all set. The first coefficient is 1, then negative 3, then negative 7, then 6. 1, negative 3, negative 7, positive 6. All right, leave a space, draw a line. Bring the 1 down. Multiply times negative 2 is negative 2. Add, plus a negative 3 is negative 5. Multiply times negative 2 is positive 10. 10 minus 7 is 3. 3 times negative 2 is negative 6. And then 6 plus negative 6 is 0. So the answer is yes. And also we get a quotient of 1x squared minus 5x plus 3. So that's actually what we could write up here as the other factor. So basically what we found is that x equal negative 2 is a 0, x plus 2 is a factor, and the quotient is x squared minus 5x plus 3. And as I mentioned before, that then allows you to find the other zeros. So I'm just going to add that as a question. What are the other zeros? Because a cubic is going to have 3 zeros. Sometimes you get some repetition, but counting repetition, you get the same number of zeros as the degree of the polynomial. So the way you do that is you set this quadratic equal to 0. And this one, I don't believe factors, so we'll go to the quadratic formula. X equals negative b would be a positive 5, plus or minus, big square root. B squared would be 25, minus 4 times a, which is 1, times c, which is 3, all over 2a. 2 times 1 is 2. 25 minus 12 is 13. So we get 5 plus or minus the square root of 13 all over 2. 2 irrational zeros, but they are real numbers, as in the previous problem. So we could see those on the graph. In fact, let's go ahead and do the rest of this graph so we can see what's going on here with all of the key points. So we've found that negative 2 is a 0, so that's going to be an x-intercept. And then these irrational zeros we can approximate on the calculator to plot them. Let me quit out of there, clear that. I've got 5 plus the square root of 13. And I did not put that in parentheses, so I need to hit enter before I divide it by 2, because it's that whole thing divided by 2. So 4.3, I'll just round it to the nearest tenth this time. And then we'll do the next one all at once, parentheses 5 minus root 13, excuse me, all over 2 is the other one, approximately 0.7, 0.7. All right, so if we look at the graph of this thing on the calculator, let's go up here. We've got x cubed, just like the previous one. Looks like I've already got this one typed in, minus 7x plus 6, which you can see if I go back over here. Always proofread if you're typing things into your calculator. Make sure that you've typed it in correctly. All right, so if I go to a standard window, which is a good thing to start, zoom 6, minus 10 to 10 on both axes, you can see that it's your typical cubic going up and then down and then up. The end behavior for a cubic with a leading coefficient that's positive is up on the right and down on the left. We've got a turning point right here, and then it goes off the screen to another turning point. I'm going to show you how to find that and change our window. So here, this 0 right here, this x-intercept looks like 1, 2, 3, 4 point something. So that's going to correspond, I bet, to our 4.3. And then there's one right here that's just to the left of 1. So that's the 0.7. And then here's the one that was nice that they were asking us about, which is -2. All right, so turning points are called minima or maxima. This is a maximum because it's a high point, and then there's one down here that's a minimum. So we can approximate those on the calculator. Finding them exactly is actually a calculus problem. But if you go second calc, maximum, number 4 there, you can find this high point, this high turning point, just like we did with zeros. You have to tell it a left bound and a right bound, what's to the left of it and what's to the right of it. You can either type in an x value like -2, or you can scroll until you're to the left of it. And then what's to the right of it? Well, 0. In fact, what I'm using for left bound and right bound here are the x-intercept of -2 and then just the y-axis, which I can tell for sure are on either side of that maximum. So that approximates that turning point to however many decimal places you want. I'll just use the one decimal place, -0.8 and 9.2 are what those numbers round to just one decimal place. All right, and then you can see that it goes off the screen. That's important to note that we aren't seeing the whole picture, but we could find that minimum value there the same way. Go second calc, minimum, option 3. And now to the left of that low point, let's just use 1, x equal 1. To the right, let's use 5. X equal 5 is to the right of it. You can see the little arrows that it puts in, so you can double check that the minimum we're trying to find is between those arrows. Yes, it is. So then you hit enter for a guess. And there's the approximation, 2.8 and -15.2. Okay, so that's our other turning point. So I'll say two turning points, 2.8 and -15.2. So you can see we need to scale our axes so they go down at least to -15.2. So I'll scale these by this y-axis by 5s here. And then we can get a good picture of this polynomial. The key points are the x-intercepts, which we found to be -2, +0.7, right about there, and +4.3, 2, 3, 4, right about there. And the turning points, negative 0.8, 9.2, right about there, 9.2, negative 0.8, just before negative 1. And then 2.8, it's right about there, negative 15.2. There's the turning point there. We know the end behavior is that it goes up to the right and down to the left. And the only other missing point is the y-intercept. And the y-intercept is really easy to find. It's just f of 0, what you get when you plug in 0 for x. And when it's in the standard form here, as opposed to factored form, it's really easy to plug in 0 for x, because all these x terms become 0. 0 to any power times anything is 0. So you just get that constant, 6. So that tells you where it hits the y-axis, technically at the point 0, 6. So right above 5 here is where it has a y-intercept. So then you can draw your polynomial going up through its turning point, down through its y-intercept, down through its x-intercept, down through that turning point, and then back up through that x-intercept. And then we have the graph, the y-intercept, the x-intercepts, if you wrote them as points, would be negative 2, 0, and then let's use the exact radical form, 5 plus or minus root 13 all over 2, comma 0. That's actually 2 x-intercepts there, the plus and the minus. And then the linear factorization of the polynomial is sometimes requested. Give it in factored form. Linear factors are just x minus each 0. So x plus 2, and then x minus 5 plus root 13 all over 2, and x minus 5 minus root 13 all over 2. In fact, I'll even show you that that does FOIL out to give you this polynomial. If you want to turn the video off at this point, you can. But this is kind of interesting. If you FOIL this out, x times x is x squared. And then negative 5 plus root 13 all over 2 times x is what you get in the middle. And negative 5 minus root 13x over 2 on the outside, and then plus 5 plus root 13 over 2 times 5 minus root 13 over 2. All right, so here, if you distribute this minus, this is going to be a plus, negative, negative. This one's going to be a plus, negative, positive. If you think about what you have there, you've got a negative 5 halves minus root 13 over 2, each with an x. And this is a minus 5 halves x plus root 13 over 2x. Let me take away this parenthesis. All right, see what I did was I put them both over 2, and I distributed the x. Put them both over 2 and distributed the x. All right, so what do we have here? We have the radical cancels out. And minus 5 half x minus 5 half x is minus 10x, 10 halves, 10 halves, 10 halves, which is 5. So those two combine to give you just minus 5x. So then we've got that x squared minus 5x. And then what's going here? These are conjugates. 5 times 5 is 25. 5 minus root 13. 5 plus root 13. Sorry, positive 5 root 13. Can you see what I'm doing here? I'm holding my phone in a bad position. my video recorder. All right, so we got a minus 5 root 13 and a plus 5 root 13. And then root 13 times negative root 13 is 13. And this is all over 2 times 2, which is 4. So those radicals cancel out. 25 plus 13 is 38. And 38 divided by 4 is 19 halves. That's not what we were supposed to get. Hold on.